Hello everyone and welcome back to part 2 of our Metroidvania tutorial series, where we'll be teaching you how you can create a Metroidvania like Hollow Knight in Unity 2D. In the first episode, we laid the foundations of our game and introduced the basic player movement. In this episode, we will take it up a notch and teach you how you can add some advanced player movements, including the double jump, the dash, jump input buffer, and Coyote Time. These mechanics are essential in Metroidvanias like Hollow Knight, as they give the player a lot of agency when it comes to their movement. They also make movement in general a lot more fun and satisfying. So without further ado, let's jump right in and get started. Let's first start organizing our project into different folders so that it will be easier to navigate and find the assets we need. We'll create art, animation, scripts, and scene folders. Then we'll drag our assets into their respective folders. Now let's add a jump input buffer. An input buffer is a feature that allows the player's inputs to be registered and stored for a brief period of time or a number of frames, even if the inputs were executed slightly before the intended time. This means that the game will remember the player's inputs and execute them as soon as the current animation or action is complete, giving the player a smoother and more responsive gameplay experience. First, we'll create another script called player state list in our player game object. This script will help us keep track of which state the player is currently in. In player state list, we can delete the start and update functions and add a public bool called jumping. Then, in our player controller, we'll add a private player state list variable called pstate. We'll set it in the start function by typing pstate equal get component player state list. This will allow us to reference our player states. Next, let's set the jumping bool. We'll set it to false when the player lifts the jump button by typing pstate.jumping equals false. Then we'll type pstate.jumping equals true to set the jumping bool to true when the player jumps. Finally, we'll want to reset the jumping bool when the player is grounded. So what we'll do is create a function called updateJumpVariables and set the jumping bool to false when the player is grounded. Then we'll add updateJumpVariables to the update function above the movement functions. Let's also move the flip function above the movement functions. Now let's add the jump input buffer. First, we'll create an if statement for when the player is not jumping. We'll add this if statement around the player jumping code. Then we'll create two private integer variables, one called jump buffer counter, which will be the variable that stores the input, and the other one called jump buffer frames, which will be the serializable variable that sets how long the max input buffer will be. Next, in update jump variables, we'll add if input.getButtonDown jump buffer counter equals jump buffer frames, else jump buffer counter minus minus. What this does is it sets the jump buffer counter to our maximum jump buffer frames when the player presses the jump button and decreases it by 1 every frame. Next, we'll go to our jump code and replace the input.getButtonDown jump with jump buffer counter is more than 0. So, when the player presses the jump button, the jump buffer counter determines whether the player will jump based on two conditions. The jump buffer counter must be greater than 0, and the player must be on the ground. The jump buffer counter is reset whenever the player inputs the jump button, and it decreases by 1 every frame. This means that the player only has a limited amount of frames determined by the jump buffer frame variable to input the jump button before the jump buffer counter reaches 0 and they are no longer able to jump before reaching the ground. Now let's set our jump buffer frames to something large like 60 in the inspector window and test the buffer out. You should see that if you press the jump button at least 60 frames before touching the ground, the player jumps. Once you've successfully tested this out, let's set the jump buffer frames to something more reasonable, like 8 frames. Next, we'll add Coyote Time to our game. In games that feature platforming like Hollow Knight, the game may employ Coyote Time. Coyote Time is a gameplay mechanic that allows the player a brief window of time to jump after leaving the platform or solid ground. Specifically, when the player character falls off a platform or runs off a ledge, the game grants the player a small period of time, typically a few frames or milliseconds, during which they can still perform a jump even though they are no longer technically still on solid ground. Coyote Time is designed to help players perform jumps more smoothly and easily, especially in fast-paced platformer games where timing is crucial. This mechanic can be especially helpful in situations where the player narrowly misses a jump and would normally fall to their death. Instead of punishing the player for mistiming their jump, Coyote Time gives them a small margin of error and helps them avoid frustration. To add Coyote Time to our game, we'll create two private float variables, one called Coyote Time Counter, which will be the variable that stores the input, and the other called Coyote Time, which will be a serializable variable that sets how much time Coyote Time will be. Then, we'll replace grounded check in our jump code with Coyote Time Counter is more than 0. Then, in our update jump variables, we'll reset the Coyote Time Counter when the player is grounded and start decreasing it when the player is not grounded. This works similarly to the jump buffer in that the Coyote Time Counter will determine whether the player can jump when it's not grounded, based on two conditions. The counter must be greater than 0 and the player must be on the ground. It decreases by 1 every second and is reset whenever the player is grounded. As a result, the player only has a limited amount of time, defined by the Coyote Time variable, to jump while not grounded, before Coyote Time Counter reaches 0 and they lose their ability to jump. Now, let's set our Coyote Time to something large like 1 second in the inspector and test the buffer out. You should see that if you press the jump button at least 1 second after leaving the ground, the player jumps. Once you've successfully tested this, let's set the Coyote Time to something more reasonable like 0.1. Note that the Coyote Time and jump buffer mechanics can be tracked using either time or frames, so you can interchangeably use the time and frame methods I've used here between these two mechanics. Next, let's add a double jump. What we want to do is create a private integer called airJumpsCounter, which will keep track of how many times you've jumped while in the air. Then we'll create a serializable max air jumps private integer, which will be the maximum number of air jumps the player will be able to do. To add our double jump, we'll add, under our jump if statement, else if, not grounded, and air jumps counter is less than max air jumps, and input.getButtonDown, jump. By implementing this line of code, the player will only jump while in the air if they press the jump button, are not grounded, and have not exceeded the maximum number of air jumps allowed. Let's then reset air jump counter to 0 when the player is grounded. Once these conditions are met, we set pState.jumping to true, increase the air jump counter by 1 to keep track of how many times the player has jumped in the air, and add the code that sets the player's rigid body vertical velocity to the jump force. Now let's set our max air jumps in our inspector to 1 to test it out. What we'll see is that our player can now jump once in the air. Before we move on, let's also organize our inspector window and move our vertical movement variables under the header Vertical Movement Settings. Next, we'll add dashing. In Hollow Knight, the dash mechanic is a movement ability that allows the player to quickly move in a chosen direction. When activated, the character will dash forward with a burst of speed, covering a significant distance in a short amount of time. The dash ability can be used to dodge enemy attacks, cross gaps and spikes, and reach previously inaccessible areas. First, let's create the dash animation. We'll create a new animation clip called player_dash. Then, we'll add in the Night Strike sprites, courtesy of the free Night Sprite asset pack from the Unity Asset Store, link is in the description below, as our dash keyframes. We'll also want to disable our dash animation's loop time, so that our dash animation does not play continuously and only plays once. Then we'll go to the player's animated controller and transition from any state to player_dash, which allows us to immediately transition to dash no matter what animation is currently playing. First, we'll set the transitions has exit time to false and its transition duration to 0. For the transition condition, we'll add a trigger parameter called dashing and set the condition of the transition from any state to player dash to the dashing trigger. Then we'll transition out of player dash to player jump if jumping is true, from player dash to player walk if walking is true, and from player dash to player idle if the other two aren't true. Next, let's go to our player controller script and create our dash. Let's first create some variables. Create a private bool called can_dash and set its default value to true. Then a dash speed, dash time, and dash cooldown private floats and make them serializable. The dash speed will set how fast the dash is, the dash time will set how long the dash lasts, and the dash cooldown will set how much time is between dashes. Let's also create a private float called gravity and set it in start to the player's rigid body gravity scale to keep a reference to our normal gravity scale. Let's also add a public bool called dashing in our player states list. Let's then create a coroutine called dash. First, we can set can_dash as false so our coroutine doesn't run again while the player is dashing. Then, we'll set the player's pState.dashing to true. Then we'll trigger the player's dash animation. We'll also want to set the player's gravity scale to 0 so that the player will dash forward without falling. We'll then dash in the direction the player is facing by setting the player's horizontal velocity to the dash speed multiplied by the player's x scale. We'll then wait for dash time in seconds to keep dashing for the dash time. We'll then reset our gravity scale, pState.dashing, and finally we'll wait for dash cooldown in seconds before setting can_dash to true and allowing the player to dash again. Then we'll call the dash coroutine by adding a function called startDash. In the startDash function, we'll want to start the dash coroutine if the player presses the dash button while can_dash is true. We'll also want to set our dash button in the input manager. Go to Edit, Project Settings, and Input Manager. Then change one of the buttons' names in Input Manager to dash, then set its binding to left shift. In Hollow Knight, the player can only dash once while in the air. How we'll recreate this mechanic is to go back to our player controller script and add a private bool called dashed. We'll then set the dash coroutine to only start if dashed is false. Once the dash coroutine has started, we'll set dashed to true so that the player can't dash once they've dashed in the air. Then we'll reset this bool if grounded is true so that the dash resets when the player lands on the ground, like in Hollow Knight. Let's then add startDash to our update function. Finally, we don't want our other movement functions to interrupt our dash. To remedy this, we'll create an if statement above our movement functions in update to check if the player state is dashing. We'll return this if statement so that the movement functions don't get called when the player is dashing. Let's then set our dash speed to 70, our dash time to 0.2, and our dash cooldown to 0.35. Now if we playtest the game, the player should be able to dash. Let's also clean up our inspector window by adding a header for our dash variables and adding 5 units of space between each section. Let's also create a dust effect for when the player dashes on the ground. First, create a game object called dash effect and add a sprite renderer. Then we'll create an animation clip for the dash effect and use the dash wind sprites from the Night Sprite asset pack as the keyframes. We'll then make it a child of the player and position it in such a way that it looks like dust is being kicked up as the player dashes by on the ground. Let's also increase the scale of the dash effect. Let's also disable our dash effects loop. Then we'll want to instantiate this dash effect whenever the player dashes on the ground. So let's make the dash effect a prefab that we can instantiate whenever we want to. In Unity, a prefab is a pre-made game object that can be reused throughout a project. It allows developers to create a template or blueprint for an object that can be easily replicated and edited without affecting instances of that object already placed in the scene. So what we'll do is we'll drag our dash effect game object to our prefab file to make it a prefab and delete the original. Then we'll reference the dash effect game object by creating a serializable private game object variable called dash effect. Let's then set the dash effect game object prefab to the dash effect variable from our game object. Let's then set our dash effect game object prefab to the dash effect in our player's inspector window. We'll then add if grounded, instantiate dash effect, transform. We'll then add if grounded, instantiate dash effect, transform under our dash line to instantiate the dash effect as a child of our player game object when the player dashes on the ground. We'll also need to destroy the dash effect once its animation has played. Therefore, we'll create a script called destroy after animation in our dash effect prefab. In the script, we'll delete the update function and add in the start function destroy game object get component animator .get current animator state info 0.length. This gets the first animation clip length and destroys the game object after the animation plays. And now after playtesting, we should have a player that has a jump input buffer, has Coyote Time, and can double jump and dash. And that's all I have for you in this episode. In the next episode, my partner Matias will cover how you, my dear viewer, can replicate Hollow Knight's melee system. Thank you for watching till the end, and I hope you've enjoyed the video. Hey there! Want to support what we do? You can help us by becoming a patron. This will give you access to the project files for our tutorials as well as patron exclusive posts on our blog. Any support you give will be invaluable to us, as currently we're only making back about 20 cents for every dollar we put into content creation. Your patronage will go a long way to help us make this a sustainable endeavor. See you in the next video!